Hey guys, they call me hardware. I'm a collection of physical elements which comprise the computer system. Some of my components include the monitor, motherboard, CPU, RAM and ROM, hard disk drive, and the keyboard. So let's take a look at my favorite, the CPU. It is the executive manager of the computer assigned tasks by the operating system. It includes the control unit, the arithmetic logic unit, and the primary storage unit, each with a certain function. And now let's take a look at the RAM. The RAM is a read and write memory. It is volatile, though it is used as a primary memory storage medium, saving the data that you are working on using electricity. The ROM is a read-only memory, which means it can neither be erased nor edited, containing parts of the operating system and storing characters in the form of codes. We've got one more component to look at. The hard drive is slower than both, as it uses magnetic fields and works through mechanical movements. It is used as a buffer and a medium to store data. Do you want to know about the computer technology timeline? The first generation had many vacuum tubes and only one electric circuit. The second, transistors and only one vacuum tube, versus the third, integrated circuits and can accommodate around 5 million CPUs. Now, let's look at the three main types of the computer systems. First is the microcomputer, which consists of only one CPU and comes in one of four types: handheld, tablet, notebook, or desktop. The mini-computer contains from 2 up to 100 CPUs, while the mainframe contains from 101 up to 1000 CPUs. And now we'll do some calculations. To be able to know which computer is the most suitable for the user, they have derived the benchmark, which integrates both transactions per minute and the CPUs. The benchmark states that 32 processors can execute 2.3 million transactions per minute. And thus, let's take a look at this example. We must assess the number of CPUs needed, and using the benchmark, we can easily do that. In this example, we realize that we need 10 CPUs. So who doesn't know the client-server architecture? It is a distributed application structure in computing that partitions tasks or workloads between the providers of resource and the requesters of resource. Now, looking at the design itself. First, we must identify the number of branches, the number of users per branch, such that we could set up switches and connect the switch to the router, either through wires or wireless. Then we must connect the router to Telecom Egypt through the WAN port. The Moist Manager must always consider the backup, WiMAX or cables. We must then reverse the same solution on the other side, telecom to the server. And at its core is the bandwidth, which depends on the nature of the work and the frequency and need of the users. Calculating the bandwidth of the server to telecom depends on the sum of all bandwidths of the branches. And now, back to my favorite, the hardware solution. Clients only need one CPU. Servers, however, depend on the benchmark, which also relies on the number of clients.
Created using Powtoon.